Hello guys, welcome back to my channel. Today we're going to be looking at the January 2019 CXC Mathematics past paper. And without further ado, we get right into the paper. Now, instruction is important. It says, answer all questions, all working must be clearly shown. And the first one, 1A part 1, says, evaluate 3.8 times 10 squared plus 1.7 times 10 cubed. Now, one must remember BIDMAS. Which tells us we have brackets, indices, division, multiplication, addition, and then subtraction. So in this case, we have indices, and we know 10 squared. We simply use a concept that if we have 10 squared, it really means 20, 10 times 10. Or if you have 10 cubed, it's 10 times 10 times 10. So I could go 3.8 times 100 plus 1.7 times 1000. Right? Now, using the concept of the zeros, 3.8 times 100 would mean you move two places. So what I'm going to end up with, I'll take out a 0, add a 0 here. I'm going to have 380 plus 1.7. Applying the same concept, I'm going to have to move three places. So one place, put a 0. Two places, you put an next 0. Three places. So you have 1,700. So I have 380 plus 1,700, which you can easily put in your calculator. This will give you 2,080. Now, it's important that we read the instruction carefully that says in standard form. Now, in standard form, the digit before the decimal point should be a number from 1 to 9. So in this case, I'm going to have to move 1, 2, 3 places. So it's going to be 2.080 times 10 to the third power. 10 to the third because we had moved three places backwards. Alright? We now move on to part 2 of the question. The second one says a half times 3/5 all divided by 3.5, giving your answer as a fraction in its lowest terms. So we're going to have to work out the numerator first. Alright? So we have a half times 3/5. Now, the concept in multiplication is that we multiply numerator by numerator and denominator by denominator. So I'm going to have 1 times 3, which is 3, over 2 times 5, which is 10. Alright? And this now is going to be divided by, we want to change the denominator to an improper fraction. So we're going to say 2 times 3 is 6 plus 1, 7. So divided by 7 over 2. Now, the simple concept here is that whenever we divide by a fraction, we multiply by the reciprocal of the second fraction. So I'm going to have 3 over 10 times 2 over 7. And conceptually, we look for things that we can reduce, right? Numerator with denominator. So 2 can go into 10 and 2 can go into itself. 2 into 2 is 1. 2 into 10 is 5. Now, once there's nothing else that can be reduced, we multiply across. So we're going to have 3 times 1, which is 3, over 5 times 7, which is 35. This can't be broken down any further, so this represents my final answer. We move to question B that says express the number 6 as a binary number. Alright, there's several ways to do it. What we can do is that we have 6 here. Binary is base 2, so we're going to be dividing by 2. And the remainder goes over here. So we say 2 into 6 is 3. The remainder is 0. Then we say 2 into 3 is 1. The remainder is 1. 2 into 1 is 0. The remainder is 1. Alright? So as a binary number, 6 would be 1, 1, 0, base 2. Alright? Binary consists of zeros and ones. And notice we stop when we get 0 down here. And of course, we start from down here. So it's 1, 1, 0, 1 in binary. Alright, let's move to the next question, which is question C. Question C says John bought a car for $65,000. If the value of the car depreciates by 8% each year, how much will the car be worth at the end of the year? Okay, So what it means is that at the end of 1 year, you're going to be taking off 8% of the value of the car. The car is going to lose 8%, which means that we always look at the original price as 100%. All right, so if you lose 8%, it still has 92%. So we can find the value of the car after 1 year. So we can say value after 1 year would be, I mean, okay, we can say it's going to be 92%, right? So let's work out the value of that. So it's going to be 92 over 100 multiplied by 65,000. Of course, we can put all this inside our calculator. So using the fraction bar, we're going to have 92 over 100 multiplied by 65,000. So that's 59,800. So that's what I should have here. This is one more zero. This is 59,800. Now this is the value of the car after 1 year, but we want it after 2 years. So this is now my 100% value, and this is now going to lose 8%. So value after 2 years. All right, so it's going to be 92 over 100 multiplied by 59,800. Once again, we put all this inside our calculator. Now, since we already had a 92 over 100 in the calculator, we don't need to delete that. We just simply deleted the 65,000. So times, this would be 59,800. So I'm going to have 59,800. This is equal to 55,016. So 55,016. Of course, you can write a statement. So therefore, the value of the car after 2 years is $55,016. We'll move on to question D. It says the table below shows the results obtained by a student in her CXC Mathematics exam. The maximum marks for the paper is given in the third column of the table. So you have paper 1, person got a percentage of 55, and the maximum mark for the paper is 30. For paper 2, the percentage is 60, and the maximum mark is 50. For paper 3, which is normally for persons who don't do SBA, they got 80%, but the value is 20%, just the same as the SBA. Now, the question is, determine as a percentage the student's final mark for the examination. There are several ways that we can work this out, all right? So let us see what happens. Now, notice the percentage that the person, this is the percentage that the person got. But of course, this is the value or the weighting of the paper. So paper 1 is weighted 30%, paper 2 is weighted 50%, which is half, and paper 3 is weighted 20%, which is just like USB. We can work them out individually. So let me say paper 1, paper 2, and paper 3. So these are the percentage, and percentage is out of 100. So it'll be 55 out of 100 times the maximum mark you can get for the paper, which is 30. This is equal to, we can put all this inside our calculator. So I'm just write them out going across. For paper 2, it was 60 out of 100 times the weight, which is 50. For paper 3, it was 80 out of 100 times the weight, which is 20. Alright? Of course, there are certain things you don't have to put in the calculator. Zeros cancel out here. So this is 16. If we could probably work this out too. 0, 0, 0, 6, 5 is 30. Alright, we could probably try a thing here. So we have 55 times 3 over 10. Let me pull in a calculator here. So I have 55 over 10 multiplied by 3. Alright, let me put that in decimal. That's 16.5. So this would be equal to 16.5. So the person's final mark, I would just simply need to add up all of these. Alright, so total would be equal to 16.5 plus 30 plus 16. This boils down to 62.5%. Alright, and of course, based on how the formula is structured, because all we did was to find 55% of the 30, 60% of the 50, and 80% of the 20, and we added everything. We could have made the formula a bit shorter. So if we have 55 over 100 times 30, obviously we would add 60 over 100 times 50 plus 80 over 100 times 20. What all these have in common is that each of them would be divided by 100. Alright? And bear in mind, when adding fractions, once the denominators are the same, we simply keep the denominator, which is 100, and we work out the numerator. So it would be 55 times 30 plus 60 times 50 plus 80 times 20. Now this, so we could have used this formula, which is known as weighted mean. So this works out how much a person would get based on the weighting of each paper, right? So we could have gone like this approach right here. All right, we move on to question 2, 2a part 1, and it says make x the subject of the formula. All right, so we have y equal x over 5 plus 3p. All right, so we need to transpose our x. We're going to start by getting rid of the 3p, which is the furthest thing away from the x. So we can subtract it from both sides, or we'll just bring it over and say y minus 3p is equal to x over 5. Now, we need to get rid of the 5 next because we need to have x by itself. The 5 is divided, so the opposite of that is to multiply both sides by 5. So, expanding the bracket, we have 5y minus 15p is equal to x. 5 would cancel, so therefore, x is equal to 5y minus 15p. And that's it. Moving to part 2 of the question, here it says solve the following equation by factorization. Of course, this is a quadratic equation, even though we don't have the constant term, which is c, which makes it easier to factorize because all we have to do now is simply take out what is common, which in this case is x. So we take out an x, we're going to have 2x minus 9 equal to 0. The concept is that if two things multiply to give you 0, one of them must be 0. So this implies that either x equals 0 or 2x minus 9 is equal to 0, which we can easily transpose this and say 2x is equal to 9 comes over as a positive. We divide both sides by 2. X is equal to 9 over 2. Right? So therefore, x is equal to 0 or 9 over 2. Right, we now move to the next question. Which is part B of question 2. And it says a farmer wishes to enclose a rectangular plot of land with fence. The width of the plot of land is 3 meters less than its length, L. Given that the area enclosed by the fence is 378 square meters, show that L squared minus 3L minus 378 is equal to 0. Now, in a case like this, all we need to do is to ensure that we have a diagram. Alright? So this is my fence. And it says the width of the plot is 3 meters less than its length, L. So let's call along this side L, which is the length. Bear in mind that length and width are just names. Since the width is 3 meters less, if this is L, the width would be L minus 3. And it says, given that the area enclosed by the fence. Alright, so we need to show that this is really what we get for the area. Now bear in mind that area of a rectangle is length times width. Alright, we know what the area is. So we're going to have length times width is equal to 378. The length is L as it is, but the width is L minus 3, which means you need to put that in a bracket. And this is equal to 378. Now we simply just need to expand the brackets here and bring everything to one side since it's a quadratic. So we're going to have L squared minus 3L is equal to 378. So it becomes L squared minus 3L bring over the 378, so it's minus 378 is equal to 0 on that side. And that is it. We can say proven true, or we can write QED, that which has been proven. Moving to part C, it says the force F applied to an object is directly proportional to the extension E produced by the object. Represent this information as an equation in the form of F, E, and an appropriate constant K. So the force is directly proportional to the extension, right? Force is F and the extension is E. Let me just start by writing that. Force is directly proportional to E, which means that force is equal to some constants K times the extension E. So force is equal to KE. Sorry, it should be F, which is force, is equal to KE. Alright, we don't know what the constant is, but let's go down here. It said the incomplete table below shows corresponding values of force and extension. Using the equation, obtain in C1 or otherwise determine the value of X and Y. So let's start with the fact that we know that the force is equal to KE. Alright? The extension and the force will change depending on what the extension is, the force change. What never changes is the constant, which means that the first thing I need to do is to find a constant K using a known value for the force and a known value for the extension. So we could use the two first set of data values. The force is 8 and the extension is 0.2. So we have K times 0.2, which means that 8 is equal to 0.2K. To get K, we need to get rid of the 0.2. We divide both sides by 0.2. So K, which is a constant, would be equal to 40. Alright? Now, writing back the formula, I'm going to have force is equal to 40 E. The constant remains at all time. So in this case, where we have the force being 25, the X value would represent my extension. So in the place of E, I would have X, and in the place of F, I would have 25. So I'm going to have 25 is equal to 40 times X. 25 over 40 is equal to X. We'll simply just put that inside our calculator. Therefore, X is equal to 0.625. We apply a similar concept for Y. We have F is equal to 40 E. Now, F is now Y. So you replace F with Y is equal to 40 times my E value, which is 3.2. So Y is equal to, and of course this again we put inside of our calculator, which turns out to be 128. Alright. We now move on to question 3 that says, using a pair of compasses, rule and pencil, construct the right angle triangle ABC such that AB is equal to 5 centimeter, angle ABC is 90 degrees, and angle BAC 60 degrees. Now the first thing we need here is a rough sketch. So let me go with AB. This is AB, which is 5 centimeters. ABC, this is 90. And it says BAC, so BAC 60 degrees. This is 60 degrees. So all we need to do with this construction is really the sketch that we have here. Alright, so let me go for my compass, my ruler, and my pencil. Now that I have my ruler, I'm going to start by drawing a line that is 5 centimeters long. I'm actually going to be using my construction line, which I'm going to use as yellow, and I'm going to use my solid line as red. So I might draw it a little longer than 5 centimeters. There we go. Let's say we go all the way out. Now using my solid line, I'm going to capture that 5 centimeters. Alright, so you go right to 5. That's where we stop. And then I'm going to move my ruler and I'm going to label that AB. So I'm going to have it as A here, B here. I'm going to put on my 5 centimeters. Now we can start by constructing the 60 degree angle. So I'm going to put the compass point at A and swing an arc cutting AB. So we swing an arc from A with the compass point at A, cutting AB. That again is my construction line. Then I'm going to move the compass I'm going to move the compass point to where it cut the arc AB, and I'm going to swing a next arc cutting this one. So let's do that quickly. So here we go, we'll swing an arc that cuts this arc. Now, by drawing a straight line from A straight through this point of intersection, what we will have here is a 60-degree angle. And because I don't know how long this line is going to be, I'm going to be using my construction line to draw it. So we ensure that this line goes right from point A straight through the intersection. Right through. And we extend it. Alright. Now I'm going to put the compass point at B because we want a 90-degree here, and I'm going to swing a semicircular arc that cuts the two sides just like that. Alright, I'm going to use these 2 points now to get my 90-degree angle. And there are several ways we can do it, but I'm going to do it the easier way. What I'm going to do is that I'm going to extend the compass to more than half the length of the line from here to here, put it here and swing an arc above, put it at this point also and swing an arc. And then I'm going to draw a straight line from B right through, which should be my 90-degree angle right there. So here we go. We swing an arc here, right above B. We're going to put the compass point at the point where it had cut, where this arc had cut 8B, which is over here, and we're going to swing an arc cutting that as well. So here we go. Alright, so a straight line from B straight through this point of intersection up to this line would produce a 90-degree angle at B. Now we can use a solid line here because this will actually be my actual diagram. So we're going to draw a straight line coming down to B. I want to ensure we stop it exactly at B, get that effect. And then of course I'm going to draw a straight line from A up to this point, which I'm going to call this point C. Alright, so here we go. Straight from A, straight up to this point here. Alright, so that's it. Now what I'm going to do is simply to label my triangle and put on the essential points. So we have A, we need to put the 90-degree at B, and we have C up here. And there goes my triangle, and don't forget to put in your 60 degrees down here. Very imperative. And that's your construction. Now do not remove your construction lines, because that is a proof that you actually constructed the triangle. We move on to part B of the question, and it says the diagram below shows a right angle triangle with sides A, B, and C units. Now what is clearly distinguishable on this triangle is the hypotenuse, which is C. It says using the diagram, express C in terms of A and B. So I'm going to be applying Pythagoras' theorem since we know the hypotenuse on the other two sides. Pythagoras' theorem says the square of the hypotenuse, which is C, is equal to the sum of the squares of the other two sides. So that's A squared plus B squared. That's pretty much it. Alright, part B says write in terms of A, B, and C an expression for sine theta plus cos theta. Now we can simply use a mnemonic to remind us. So, ka, toa. Alright, so sine is opposite over hypotenuse, which would be A over C, and cos is adjacent, which is B over hypotenuse, which is C. So let me just give some space here. So we can say that sine theta is equal to A over C, cos theta is equal to B over C. So sine theta plus cos theta would imply A over C plus B over C, which you can write as a simpler expression. The denominators are the same, so we go A plus B all over C, and that's my expression. We now move to the next question that says using the results from 1, A and B on page 12 show that sine theta all squared plus cos theta all squared is equal to 1. Okay, now recall that sine theta was equal to A over C. So sine theta squared would be A over C all squared, which by laws of indices would be equal to A squared over C squared. Cos theta was equal to B over C. So cos theta all squared would be equal to b over c squared. When you square a fraction, you square the numerator and you square the denominator. Good. So this means that sine theta all squared plus cos theta all squared would imply a squared over c squared plus b squared over c squared. Once again, the denominators are the same. So you're going to have c squared, you have a squared plus b squared. But recall, according to Pythagoras' theorem using the same triangle, a squared plus b squared is equal to c squared. Let me take this down. So this is going to become c squared over c squared, which is equal to 1. And that's exactly what we wanted. So QED. We now move on to question 4. And it says, given the function h of x is equal to 2x plus 3 all over 5 minus x, determine the value of x for which a function is undefined. Now, a rational function is undefined when the denominator is equal to 0. So, we would say let 5 minus x equal to 0. Alright, since x is negative, we could bring it over. So 5 is equal to x. So, therefore, a function is undefined, right, when x equal to 5, right? Alright, part 2 says, find an expression or determine an expression for the inverse of h of x. So we have 2x plus 3 over 5 minus x. Let me start by writing that down. Now, the first thing we want to do in the procedure is to let h of x equal y. So we have y equal 2x plus 3 over 5 minus x. Then of course we know we interchange x and y. So you're going to have x equal 2y plus 3 over 5 minus y. And then we solve for y. Now, in solving for y, one of the first things we always do whenever we have fractions is try to get rid of the fraction. So we're going to multiply both sides by the LCM. So it's x times 5 minus y is equal to 2y plus 3 over 5 minus y times 5 minus y. Right? And we use a bracket. So we have 5x minus xy equal 2y plus 3. Now bear in mind that we're solving for y, so we need all the y's on one side. Good? So I'm going to have to, well, we can do one of two things. We can bring over the xy, bring over the 3, or you can do it vice versa. So I have 5x minus 3 equal 2y plus xy. Once we have y's, all the y terms on one side, we can factor out the y. So we have 5x minus 3 equal, factor out the y, we have 2 plus x. Alright, we need y by itself. So we have to get rid of the 2 plus x, which is multiplying. So we divide both sides by 2 plus x. Let me fix this right here. Over 2 plus x. Alright, so y is equal to 5x minus 3 over 2 plus x. So therefore, h inverse of x is equal to 5x minus 3 over 2 plus x. And that's my inverse function. We now move to part B in the next question. Alright, it says a graph shows a straight line intersecting the x and y axis. And if we look carefully here, notice that if 2 is here, then if we want to put on some numbers, this must be 1, this would be 3, up here would be 4. Likewise down here, this is 1, this is 3, and this of course is 5. It says using a graph, determine the gradient of a line. We know gradient to be rise over run. Good? So we can say, call it m is equal to rise over run. Now the line here is slanting downwards, right? Which means that the rise is going to be negative. So I'm going down from this point, starting at this point here, at the intercept, 1, 2, 3, 4. So this would be equal to negative 4 over the run, which would be 1, 2, 3, 4, 5 over 5. If we want, we could say negative 4/5. All right. So that's the gradient of my line. Now let's move to the next question. The equation of a line. Now, the equation of a line we know is y equal mx plus c, where m is the gradient, c is where the line cuts the y-axis. So let's go back and look. We found the gradient to be negative 4/5. The line cuts the y-axis at 4 or at 0, 4, so the y-intercept is 4. Alright, so we have both components that we need. So this would be y equal negative 4/5 x plus my y-intercept, which is 4. And that's it. Part 3 says the equation of the line, or the equation of a perpendicular line passing through P. Alright, so let's go back and see what is happening. Alright, passing through P. So P is right here at at 5, 0. The x coordinate is 5, the y coordinate is 0. So the coordinate there is 5, 0. So let me put down this information. P is 5, 0. Now what else is also important in this question? It says the perpendicular line. Now when two lines are perpendicular, the gradient of one is the negative reciprocal of the other. So it means that the gradient of this particular line is the negative reciprocal of the previous one. So the gradient would be 5 over 4, right? The negative reciprocal. So using y equal mx plus c, we know the gradient. The only thing we don't know is the y-intercept, which is c. Right? So let me put in information that we know. So y equal 5 over 4 x plus c. Since we don't know c, we're going to have to find it using the coordinate that we know, which is 5, 0. So it means that when x is 5, y is 0. So I'm going to have 0 equal 5 over 4 times x, which is 5, plus c. So 0 equal 25 over 4 plus c. So we can say negative 25 over 4 is equal to c. So therefore, y is equal to 5 over 4x plus my c value. And since it's negative, we're going to have minus 25 over 4. And that would be the equation of a line perpendicular passing through P. Alright, we'll move on to question 5 that says a survey was conducted among 48 persons to find out what mobile network they use. The table below shows the results of the survey. So we have the mobile network, Wiretech, Digilec, OFO, and other. And then we have a corresponding number of persons. Now the first question is, if the information were to be represented on a pie chart, what is the angle for the sector that will represent OFO? Now bear in mind that pie chart is like a circle, which is equal to 360 degrees. So we want to know what fraction of the circle is OFO. Right? So it's going to be 10 out of the total that we have, which is 48, times a revolution, which is 360 degrees, right? And then we can put all this inside our calculator. This would be equal to 75 degrees. Please do not leave off degrees, right? Moving to A, part 2, it says using the circle below with the radius shown representing information in the table on a clearly labeled pie chart. Alright, so we're going to need to calculate the angle for each of the other things. So we need Wiretech, we need OFO, and we need other. Alright. Now let me see. Wiretech has 20 persons. That's going to be 20 out of 48. Let me just write it as WT, Wiretech. So it's 20 out of 48 times 360 equal. So that's a wire phone. We're also going to have our Wiretech. We're also going to have Digilec, which is 12. So let's call it DL. Digilec, so that's 12 out of 48 times 360. And of course, our calculator can do all this work. This is going to be 150 degrees. This is 90 degrees. OFO that we worked out already is 75 degrees. Now, since everything add up to 360, we'll go back up and look at the table again. If everything adds up to 360, we can easily work out other, which is 6 there, because we just simply need to add up all of these and subtract it from 360. So let me call it O for others. So O would be equal to 360 degrees minus the sum of the others, which is 150 degrees plus 90 degrees plus 75 degrees. Once again, that is calculator work. This is equal to 45 degrees. Also, we never had to work it out because I believe that DL is 12 and this is half, so it will be half the amount of degrees, right? Now, once we have this, the next thing we need is our protractor, so we can measure the different angles away from the radius here. Now, when using the protractor, we can use the inner or the outer, depending on which is on the 0 mark on your radius. Now, if you look at my 0 mark would be my inner part, and that is on the 0 line. So let me look for the biggest one, which is y-tech, which is 150 degrees. So find 150, which is right here, which is aligned with 30. What I'm simply going to do is to put a mark right there. Now I'm going to draw a line from the center of the circle right to the edge where this mark is aligned, as you can see, right down to the circumference. And that would be my 150 degrees, which is y-tech. We'll simply put in the y-tech. Now, if we move into Digiloom, we can also measure this 90 degrees away from this line, or you could measure it away from the other line. It doesn't really matter. Let's go again. Now, Digilec is 90 degrees. So notice that my 0 line is down here. So we're going to measure all the way. It's also the inner one, which is right here. And then we're going to do the same thing and draw a straight line from that point up to the center of the circle. So here we go. Ensure it's lined up with the center. We draw a straight line that stops right at the circumference, right? And we can put in the angle, and we'll put in what the thing represents. So here, this is 90 degrees. Of course, this is Digilec. Alright, and then we have O phone, and of course, automatically, once we have put in O phone, whatever is left will automatically represent others. Once again, I'm using the inner one because it starts from 0 going all the way around to 75. I'm going to put a dot. 75 would be up here, would be right there. Alright. So we're going to draw a straight line from the center all the way up. Let me catch this again. So here we go. All the way up to the circumference, which is where we stop. So there we go. Let me just remove my protractor. So we know that this here is my 75 degrees, which is O phone. And then automatically this would be your 45 degrees. And this is other. So we just have to be careful, alright? We can also measure the angle to make sure this is 45, because I know that once this is 45, all the other angles would probably have been done correctly. We'll move on to part B that says the incomplete table below shows the results obtained by 200 boys and 250 girls on a Spanish examination. So we have the different grades and we have the number of persons. A girl is chosen at random. Determine the probability that she achieves a grade 1. So a girl is chosen at random. What this means is that we are focusing on just the girls. So you can say probability girl gets grade 1. Alright, a little statement there. Be equal to, you have 62 girls getting grade 1s out of 250. Alright? And we'll break this down. Now, of course, the results are not combined because it's a girl is chosen at random, which means that we know that a girl is chosen, which means that becomes our sample space. Alright, and we'll break this down. 2 can go into both of them, so I'm going to have 31 over 125. Part 2 says, what percentage of the boys who took the exam achieved grade 1 to 3? Now let's go back quickly and look at the table. Alright, so we know that there are 200 boys overall. 30 got 4 and 5. So it's going to be 38 from the 200 to tell me how many got from 1 to 3. Alright, let's go back. So the number who got from 1 to 3. Alright, so the number equal 200 minus 38. Now 200 minus 38 is going to give me 162. Good. And it says what percentage of the boys who took the exam. So we want this in percentage. Now percentage is out of 100, so it would be 162 out of 200 multiplied by 100. And of course, we can put all this inside of the calculator. This boils down to 81%. Alright, and bear in mind that from grade 1 to grade 3 would actually be your passes. Now part 3 says, considering the standard deviation in the table on page 18, compare the performances of the boys and the girls. Let us go back and look. Now the standard deviation for the boys is 8.2, for the girls is 6.3. Standard deviation is a measure of the spread of the data. So this is telling me that the data for the boys is more widely spread out. Alright? The girls are more concentrated. Now let us look at the pass mark. Up here we notice that from 1 to 3, the majority of the girls would have been concentrated around here. If we were to add up all of these values, we approximately would get 200 and odd. As opposed to when we checked the amount for the boys, it was 162 out of 200, which means that there's a greater percentage of girls who are doing better in this region, as this was 81%. Up here would actually be something like 90 odd percent. So this is telling me that the girls actually did better in this exam than the boys. Alright? We're not watching the amount of boys and girls that did it, but we're looking how the data is distributed around the region. So we're seeing a greater performance or a better performance from the girls than the boys. And the standard deviation tells me that the boys has a larger spread as opposed to the girls. We move on to question 6. It says the diagram below, not drawn to scale, shows an open cylindrical container made of metal with a circular base and uniform thickness throughout. So here's my circular base and the thickness throughout is uniform. The length of the container from the top to outer bottom is 120 centimeters. The inner and outer radii are 14 and 15 centimeters respectively. Alright, and take pi as 22/7. Draw a cross-sectional view of the container showing the measurement of the inner and outer radii. Now the cross-section is the section going across. It doesn't matter where you cut the container, you will see the same. So we can just simply look at the top here. Let me just get some space. So my cross-section, well, let me go for my compass so I can get a better diagram. So let me draw my outer circle first. And let me draw my inner circle. It just needs a bit of adjustment. There we go. Alright, so we don't need that. So now we need to put in radius. So this is 14 centimeters. And of course the outer one, so from the center to the outer is 15. What I really need to do is simply just extend this line. So I could extend this line and I put 1 centimeter here, which tells me that the inner is 14 and the outer is 15 from the center here. Now part B says show that the capacity of the container is 73,304 cubic centimeters. Now the capacity is how much it holds. Now let us go back and look at the container again. Alright, so the capacity would be how much this inner part here can hold. Just this part here. Now notice one very important thing. It says the thickness is uniform throughout. So if the thickness of this wall right here, which is the material, is 1 centimeter, it means also the thickness down here is also 1 centimeters. So instead of being 120, this inner cylinder here is going to be 119 in terms of height. And of course the inner radius here is 14. So let us go back and see if we can produce a diagram. So I would have something like this. My inner cylinder where this is 14 as my radius and my height would be 119. Of course, down here where you would have had the material, 1 centimeter would have come off. Good, so let's go. So you can say that the capacity equal, and of course for a cylinder, the volume, and of course this is the volume of the smaller cylinder, is pi r squared h. Now we were told to use pi as 22 over 7. So it's 22 over 7 times 14 squared times 19. And whereas, as we said before, we can put all this inside our calculators. And in fact, I'm going to pull up the calculator. So it's going to be 22 over 7. That's times 14 squared. So 14 squares right here on the calculator times 19. And this is equal to, well, this shouldn't be 19. This is actually 119. So there's an error there. So this is 73,304. Initially I had put 19, but it's supposed to be 119. So see how we get in the volume. Alright, so this would be 119 to 73,304 cubic centimeters. Alright, QED, as this would have been a proof question. Now part C says determine the volume of the material used to make the container. Now let me just go back and give you a quick sketch. Alright, so the material has some thickness here. Good. Now we have actually found the interior capacity or the inner volume, right? If I were able to find the volume of this larger container and I take out the inner volume, which is the capacity, then of course I would get the volume of the material, because what would be left if we were to take out the inside is the volume of the material. So the volume of material would be equal to inner volume minus the outer, well, not inner, the outer volume minus the inner volume, so to speak. So outer volume, we call V, minus inner volume. So the inner volume is the capacity, which we already have at 73,304. So we just need to find the volume of a larger container here. Now, bear in mind this is 120. And of course, for the larger container, the radius is 15. So if I am able to find this entire volume and I'm able to subtract the capacity, I'm going to get the volume of the material. So this is going to come down to pi r squared height also, because this is also a cylinder. Alright, so it's going to be pi r squared height minus the 73,304, which is the capacity. So it's 22 over 7 times 15 squared times 120 minus 73,304. Good. Now let me pull up the calculator here. Give me some space. Now all I need to do is go back and probably clear, right? So let me see if I can go back here. So this is going to be 120. And if I go back, I'm going to change the 14 to 15. Alright, we can even subtract the 73, so I can say minus 73,304. Alright, and we change that to decimal. So that's 100, well, that's 11,553 that's a 0.1. So that's going to give me 11,553.1 of cubic centimeters. Now the final part of the question says, given that the density of the material used to make the container is 2.2 grams per cubic centimeter, determine the mass in kilograms of the empty container. Alright, so density is equal to mass over volume. We're told that the density here is 2.2. What we want is the mass, and we know the volume. So let's go back and look at the volume. That's 11,553.1. So that's 11,553.1. So we can just multiply across to get the mass. So the mass is equal to 2.2 times 11,553.1, which is going to be equal to 5,416.82. Do not leave off units, which is kilograms. We now move on to question 7. It says a sequence of figures is made from joining polygons with sides of unit length. The first 3 figures in the sequence are shown below. As you can see, figure 1, figure 2, figure 3. Draw figure 4 of the sequence. So you're going to be using your ruler to draw this, alright? I'm just going to be doing freehand. So notice that this has one of these, this has 2, this has 3. So the next figure will naturally have 4. Let me see if I can divide this into 4 equal parts. 1, 2, 3, 4. Alright. Let me just extend this a little. Bring it up. Alright. Of course, when you use a ruler, you should get a neater figure. Let's see if I can make this as neat as possible. Alright, these are broken lines, so we need to ensure that it's consistent. So you use your rulers to get the line straight. So that would have been the figure. Part, he says, study the pattern of the numbers in each row of the table below. Each row relates to one of the figures in the sequence on page 23. Some rows have not been included in the table. Complete row 1, 2, and 3. Alright, so let's go. So we have figure 1. So we have 1 plus 1 plus 2. This is the number of lines of unit length, and this is the perimeter. So we have 1 plus 2 plus 2, which is 5. Then for 2, we have 2 plus 2 plus 4, which is 8. And for 3, we have 3 plus 2 plus 6, which is equal to 11. Alright? Now, for 6, what would happen? Following the pattern, this would be 6 plus 2. Alright? So we don't even have to think about those two. So it's whatever you have over here, the figure, plus 2. Now look at the relationship between the figure and 2, 4, and 6. Each of these numbers are double what this number here is. So I know that if this is 6, then this must be 12. Now 6 plus 2 is 8, and 8 plus 12 will give me 20. So that's figured out. What about when I have 65? To do this smartly, I would probably want to go with n first, which is going to be n plus 2 plus, of course, n plus 2 plus whatever you have here doubled. So it would be 2n. Alright? Breaking this down, this is just equal to 3n plus 2. So what it means when I have 65, I know that 3n plus 2 will be equal to 65. So I can work that out. 3n plus 2 equal to 65. 3n is equal to 65 minus 2. 3n is equal to 63. I will divide both sides by 3, which means that n is equal to 21. So n is 21 here. So I'm going to have 21 plus 2 plus twice 21, which is 42. And that would complete my table. So you quickly get 6 easy marks. We now move to section 2, and the instruction is answer all questions. Please read it carefully. It says complete the table below for the function. Now, one of the things I want to do is you can use a calculator to actually plug these in. But to plug this inside of your calculator, going for f of negative 2, which is 3 plus 2, open bracket, negative 2, minus negative 2 squared. If you don't use a bracket, then the answer is actually going to be wrong. Now, I don't need to manually work this out, but let me just do it. So it's going to be 3 minus 4 minus, and this would be positive 4 as well. So this comes down to 3 minus 4, that's negative 1. Minus 4, it's negative 5. And then we also have a missing data value for 2. So we have f of 2 equal 3 plus 2 times 2 minus 2 squared, which is 3 plus 4 minus 4, which is equal to 3. So this data value right here would be 3. The next question says, complete the grid below to show all the points in the table on page 25 and hence draw the graph of the function f of x. So I'm going to need to pull in the points. So let me create some space here. Alright, so here we go. We have negative 2 with negative 5. So let me just bring this up a little. Alright, there we go. Negative 2 on the x-axis, which is here. Negative 5 on the y-axis, which is down. So put an x there. We have negative 1 with 0, which is already in. We have 0 with 3, which is in. We have 1 with 4, which is in. We have 2 with 3. So 2 with 3. You put an x there. And then you have 3 with 0, which is in. And you have 4 with negative 5. So I'll create a space here. Oh, that is also in. So all we need to do now is to draw this graph. Alright, so bear in mind this is a freehand graph. Alright, try to get it as smooth as possible. And ensure that it goes through the points, right? Alright, your graph should actually be neater than mine. Let me see if I can fix this part. So if there's a part that is not so smooth, you can always rub it out and try to catch it as much as possible. I'm using the computer screen, so it's a bit technical. Ensure you don't have any double line. Alright. Now let's move to the next question. It says the coordinate of the maximum point of f of x. Let's go back. The maximum point is a point where the graph turns. And this would be at 1, 4. So that would be the coordinate of my maximum point. Alright. So this is simply just 1, 4. The range of f of x, where f of x is greater than 0. So the range of f of x, the range of values of x for which f of x is greater than 0. Alright. F of x is greater than 0 means that the part of the graph, that part of the graph is above the x-axis. Alright, so the y values are greater than 0. Now, if we look at the part of the graph that is above it, it is from x is negative 1 to x equal to 3. Alright, so let's go back. So it would be x is greater than negative 1, but x is less than 3. Alright, let's scroll this down. The gradient of f of x at x equal to 1. So let's go back. Now, at x equal to 1, let's go back this point. To get the gradient, I would have to draw a tangent to that point. Now, notice that the tangent would be a flat line, which means that the gradient would be 0, as there is no rise. So the gradient here would simply be m equals 0. Alright? And that will wrap up the question. Now we move on to part B. It says, Mr. Thomas makes X bottles of juice and Y cakes each day. To supply his customers, he makes at least 20 bottles of juice and no more than 15 cakes each day. Alright. Now write two inequalities to represent this information. Now it says he makes at least 20 bottles of juice. So it means that the number of bottles of juice can be 20 or more. X, which is the number of bottles of juice, is either going to be greater than or equal to 20. No more than 15 cakes. So the number of cakes is either going to be 15 or less. The number of cakes is represented by y. So y is either going to be less than or equal to 15. Alright, so that's for part 1. Part 2. Each day, Mr. Thomas uses $163 to make the bottles of juice and the cakes. The cost to make a bottle of juice is $3.50, while the cost to make a cake is $5.25. Write an inequality to represent this information. Okay, so the total amount of money he's spending is $165. the cost to make a bottle of juice is $3.50. Alright, so the number of juice, or the cost to make the juices, if he makes X juices, it would be 3.50 X. If he makes Y cakes, it would be 5.25 Y. And of course, he's spending $160 to make the bottles of cake and juice. The cost to make a bottle of juice is $3.50, while the cost to make a cake is $5.25. Write an inequality to represent this information. Good. Now the cost of making the juice and cake cannot exceed $163. So it must be less than or equal to 163. That's how we get the next inequality. Alright. Let's see what happens next. Alright, part 3 says, show that on any given day, it is not possible for Mr. Thomas to make 50 bottles of juice and 12 cakes. Alright, so let us go back. Now, since he's spending $163, any information inputted into this must be less than or equal to 163. So I'm have 3.50x and 5.25y. So let me go back. 3.50, 5.25 times 50 is 5.25 times 12 should be less than or equal to 163. Now we're going to put this into the side of our calculators and see if it works. This boils down to 238, which is not less than or equal to 163. Not true. So hence it's not possible, because any value that I get over here must either be less than or equal to 163. So this would have failed. So it's not possible to make 50 bottles of juice and 12 cakes, any at all. We move on to question 9. It says the diagram below, not drawn to scale, shows a circle. The points P, Q, R, T, and V are on the circumference. QRS is a straight line. So QRS, so that's a straight line. Angle PVR is 75. So PVR is 75. And angle TRS is 60 degrees, which is out here. It says, the first question, determine the value of each of the following angles. Show detailed working where necessary and give answers to support your answer. So it says PTR. So PTR. Of course, PTR would be 75 degrees because these are angles in the same segment. You have PVR and PTR would be the same angle as their angles in the same sector. So this would be equal to 75 degrees, angles in same segment. I said sector, it should be segment, in the same segment. Part 2 says angle TPQ. Now let us go back. So TPQ. Now this is interesting how we're going to go about finding this. Because if you look at this figure right here, you notice a cyclic quadrilateral. And in a cyclic quadrilateral, opposite angles add up to 180 degrees. So if I can find this angle here, because this is a straight line right here, so it means that TRQ would be 180 minus 60. Good. So this would be 120 degrees. Alright? And of course, opposite angles in a cyclic quadrilateral add up to 180. So it means that up here would be 60 degrees. So we would have gone back to the question. I would have written all that information right there. And then it says obtuse angle POR where O is the center of the circle. So POR where O is the center of the circle. Let's go back. So I'm gonna have POR. So I'm gonna put O here. So imagine that this is the center of the circle right here. And then we come down here. So on this angle right here, theta. Alright, now looking at this, we say that the angle at the center is twice the angle at the circumference. That is the reason. Angle at center is twice the angle at the circumference. drawn from the same point. Alright? So, are drawn from the same arc. Sorry. So notice here now, this angle here would be 2 times 75 degrees. So P, and put the O here, POR would be 2 times 75. The reason being, angle at center is twice angle at the circumference drawn from the same arc. So this would be 75 degrees. Alright? So you could just go back to the question, put in the reason, and put that as 75 degrees. Right? And that would be the end of that question. We now move to the next question. B, it says a person at the top of a lighthouse, TB. So this is lighthouse TB. Sees 2 ships approaching the coast as illustrated in the diagram. The angle of depression are 12 degrees and 20 degrees respectively. The ships are 110 meters apart. So this is 110 meters. Alright? This is my lighthouse, so you can put on that labeling there. So it's the angles of depression. So you know that this would be a smaller angle, which is 12 degrees. The larger angle would be 20 degrees. Alright? And then of course you have what we call alternate angles. So it means that down here would be 12 degrees and over here would be 20 degrees. We also call them Z angles, as you can see. Alright, complete the diagram below by inserting the angles of depression and the distance between the ships. So we have that information. Let me just scroll up a bit here. Determine to the nearest meter distance TS2, so this distance right here, TS2, between the lighthouse and ship 2. Now if we're going to find TS2, let me kind of edit this information right here so we have better. This is 20, that is 12, it means that in here says 8 degrees. Alright, we know that down here is 12 degrees, so we can actually find this angle. Because the angles in a triangle add up to 180. So 8 plus 12 is 20. So this means that over here would be 160 degrees. The angles must add up to 180. Now, so we have this information, which means that we have enough angles to use the sine rule. Alright, so we can say TS2 over, of course, the angle opposite TS2 is 160. Our sine 160 degrees would be equal to this side over the angle up here that I know. So it would be 110 over the sine of 8 degrees, right? Because this side is opposite this angle. And the 160 is opposite TS2. Alright, so we can multiply both sides by sine 60. So we can say TS2 is equal to 110 over sine 8 degrees times the sine 60 degrees, 160 degrees. Now, we never work out the first part initially because when you put in all information one time, you're going to get the most accurate answer. And it says determine to the nearest meter. Alright, so we're going to put all this inside of the calculator now. So we have 110 over the sine of the sine of 8, close bracket, multiplied by the sine of 160. Alright, please close your brackets. This is equal to 270.3. And it says round to the nearest meter, so it would be 270 meters. This is equal to 270 meters. Put this here, 270 meters. And the instruction did say round to the nearest meters. And let's see what the next question has to offer. The height of a lighthouse TB. Alright, let's go back and see what we need. So we need this height right here. So we're just going to take out this triangle right here, which is the larger one. We know that down here is 12 degrees. Alright. We know that over here is 270, which is the hypotenuse. So we want this side. So let me just do a quick drawing. So over here is 270. TB. This is a right angle triangle. That's 12 degrees. Now we want TB, which is this side, which is opposite to the angle, and we have the hypotenuse. Now that reminds me of sine. So we can say sine 12 is equal to TB over 270. Alright? We'll simply just multiply both sides by 270. So we can say TB is equal to, and then again, this is the next job for the calculator. So let me pull up the calculator. So I'm going to have 270 sine 12. And please close your brackets. This is equal to 56.1 or 56.1. It's 56.1 meters. Let's go back and see if they wanted us to round everything to the nearest meter. So previous, determine to the nearest meter. Yes, so it would also fall under that instruction as well. So this would just be 56 meters. Alright, round it to the nearest meter. And that's the end of the question. We move on to question 10 that says three matrices are given as follows. So we have the three matrix. We have a 2 by 2, 2 by 1, and the next 2 by 1, which is R. It says using calculation to support the answer, explain whether P is a singular or a non-singular matrix. Alright, we have a statement. I just wrote the statement in fact. It says if singular, the determinant of P is equal to 0. Right? So we're going to go ahead and find the determinant. Determinant of P be equal to -1 times 5 minus 2 times 0, which is equal to -5 minus 0, which is -5. So P is non-singular. Alright, let's move on to the next question. So what happens? Part 2. Given that PQ is equal to R, determine the values of A and B. Let's go back and look at what P was, what Q is, and what R is. So previous. So P is -1, 2, 0, 5. Q is AB, 11, 15. So we have -1, 2, 0, 5 times AB is equal to 11, 15. Alright, let's see. So we're going to have to take the product here first. And we know it's row times column. So it's -1 times A plus 2 times B, which is just 2B. Then you have 0 times A plus 5 times B, which is 5B. Alright, and this is equal to 11, 15. So when two matrices are equal, things that are in the same position are equal. So you're going to have minus A plus 2B is equal to 11. And 0A, that's going to be 0. 5B is equal to 15. So we have two equations. Equation 1, equation 2. Now from equation 2, we can easily solve that. Dividing both sides by 5, we have B is equal to 3, which we're going to sub in equation 1. So you're going to have -A plus 2 times 3 is equal to 11. -A is equal to 6. Well, -A, so this will be plus 6 is equal to 11. So -A is equal to 11 minus 6. -A is equal to 5. I will divide both sides by -1. A is equal to -5. And then of course you can write your final statement. Try not to write past this broken line here. So therefore A is -5 and B is equal to 3. Part 3 of the questions is state why the matrix QP is not possible. Let me go back and look at Q. Previous. So Q times P. Alright, why is it not possible? Now notice if you're going to multiply Q by P, you'll be multiplying a 2 by 1 matrix by a 2 by 2 matrix. And that is not compatible. For it to be compatible, the number of columns of the first matrix must be equal to the number of rows of the second matrix, which is not true in this case because this is a 2 by 1 and this is a 2 by 2. Alright? So we'll just write that as a statement. That for the matrix to be compatible, the number of columns of the first matrix needs to be equal to the number of rows of the second matrix. The first matrix has 1 column and the second matrix has 2 rows. So therefore they are not compatible. Let's move to the next question and see what's going on. Alright, it says OABC is a parallelogram, which is down here. X is the midpoint of AB and Y is the midpoint of BC. OA is equal to R and OC is equal to S. Complete the diagram below to represent all information given. So we have OA, we need to put on the B, we need to put on the C. X is the midpoint of AB, so in the middle of here, I'm going to have X. And Y is the midpoint of BC, so in the middle of BC, I'm going to have Y. Now, OA is R, so put on the direction arrow there. OC is equal to S, so put that on there. It said given that OX plus OY is equal to K into R plus S, where K is a constant, using a vector method, find the value of K. Let me create some space here. So the first thing I need to find is what is OX. So OX will be from here to here. Now in a parallelogram, opposite sides are equal. So we can say that OX is equal to, going from O to X, OA plus AX. Of course, AX is half AB. Now AB would be S because AB and OC are equal. Alright, so this will also be S up here. So OX would be equal to R plus a half S. Let's talk about OY now. Going from O to Y, OY would be equal to OC plus CY. Alright, and over here, so opposite sides are equal, so over here would be R as well. And we're going in the same direction. Now OC is equal to S and CY is equal to half R. Now let's add them. OX plus OY will be equal to R plus half S plus S plus half R. Of course, you know we're going to combine like terms. So R plus half R would be 3 over 2R. And a half S plus S. Of course, you know, when adding these like terms, we just add the coefficient. We add a half and we add 1, which is 1.5. I'll write it as an improper fraction, which is 3 over 2S. So to make these two things look alike now, I would need to factor out what is common, which is 3 over 2. And we have R plus S. So therefore, K must be equal to 3 over 2. And that is the end of the 2019 January CXC Maths resit paper, or the CXC Maths paper 2.